Thank you very much. Moving on, I will just introduce something a bit different in the essence that we are not going to talk about a specific EU project, rather than we are going to talk a bit about the Laboratory for Manufacturing Systems and Automation. I'm a research engineer at the specific laboratory. It's based at the University of Patras in Greece. And actually, we are going to see a bit of our activities and what we do in different projects, mostly on additive manufacturing, but also we will take a look at what we do in what we call the Advanced Processing Group. So, as mentioned, the Laboratory for Manufacturing Systems is oriented in research and development in cutting-edge scientific and technological fields. So far, we have been fairly successful as an organization, taking part in more than 100 European projects. At the moment, we are employing about 70 people, and we have organized more than 10 international conferences and published more than 500 scientific articles. We are organized in 3 different groups. The first one is the Advanced Manufacturing Processes Group. This is the group I actually work on, and we deal with any kind of processes is available in modern manufacturing, and we do anything from modeling to simulation, monitoring, and optimization of processes. We also have 2 different groups dealing with manufacturing. The first one is manufacturing automation, robotics, and virtual reality application. And the second one is regarding manufacturing systems, so modeling, planning, and decision-making, knowledge management, and engineering to order or customization. So I'm going a bit more into detail on the manufacturing processes group. And here you can see indicative organizations we have worked with on the past in the context of European projects. What I must note here, and actually what you are going to see, to eyewitness quite a lot of it in the coming slides, is the fact that unlike most universities and most laboratories, what we do is research driven by industrial needs. So we give particular emphasis in cooperating with industries and trying to solve their needs through science and through novel developments. Indicative topics of what we do. Of course, additive manufacturing, and this is the reason actually that most of us are here these days. We deal with a large number of different processes, and actually we have dealt with that topic since 1997, ranging from polymers and FDM or up to different laser-based metal or plastic processes, such as selective laser sintering and direct metal deposition. Of course, we don't only do additive manufacturing. We are also dealing with a great range of forming processes. Either is that roll forming or laser-assisted forming, superplastic forming, and resin film infusion, up to composite manufacturing ways such as vacuum-assisted resin transfer molding. We are also dealing with joining processes, material removal processes, and advanced surface treatment processes, again in terms of modeling, simulation, monitoring, and optimization. Few words about some projects we have been involved in the past, not directly related to the field of additive manufacturing, but definitely related to the field of advanced manufacturing. The first one is the ForteSSIN project. It was a 7th framework project running in LMS, along with a series of very important industrial partners. The result of this was a manufacturing information pipeline platform which allowed to reduce machine idle times by 25%, reduce idle times by 40%, increase machine availability by 60%, and significantly reduce consumables down to the half, as well as increase the competitive advantage of a European manufacturing industry by 30%. The second one is AnyPlan. It is along the same lines. So AnyPlan dealt with creating a MetaCam tool, which is basically a web-available tool able to assess the complete manufacturing chain. That means that in there, what we did is integrate process models, try to evaluate the impact of each one, and try to suggest alternative manufacturing methods for the SMEs. Of course, besides the actual process modeling, what we did is monitoring of the production and provide tools for different suppliers or different supply chains and be able to simulate multiple what-if scenarios in order to validate the impact and the outcome of different scenarios in production. Third one would be RLW Navigator. This is a project that very recently ended, and it was regarding remote laser welding of automotive parts mainly. What we did there is find a way to actually monitor the laser welding process. We went on through modeling the actual welding process, and we established quality metrics as well as the equipment in order to be able to assess the quality of the welds as the process goes. The final outcomes of this project was a significant reduction to the assembly time when compared to resistance spot welding that is a common standard for the automotive industry, reduced significantly the factory footprint compared to systems without remote laser welding, and also reduced the energy needed to create a solid joint when compared to more traditional methods. Another project which is currently running and is on the second year is SimoDS. SimoDS is a bit different in the essence that what we are trying to do here is look at the complete production line of two different automotive suppliers and find ways to reduce waste and scrap by modeling the process and try to identify what causes the faults in their production. So in essence, it's a zero-defect manufacturing process. Through monitoring and modeling, we're trying to find where the defects come from and how they can be counteracted. Next is MASHES. MASHES is a very interesting project also for our additive manufacturing activities, and this is because it regards multimodal spectral control of laser processing with cognitive abilities. Here, what was done as the core development of the project is the development of a monitoring system for laser processing, which allowed a very fast and low-cost solution to be implemented in a laser head. The developments here were tested against two different cases. The one was laser welding, but the second one, which is of very high importance to us, was regarding laser cladding and laser metal deposition. And here, the algorithms that were developed allow almost real-time control of the process variables, of a lot of process variables, such as laser power, laser modulation, laser speed, in order to achieve the desired result. Another project also currently running at this point of time, it is something that a lot of people are actually asking when talking about additive manufacturing. And this usually, the question usually is about, do you do anything with additive manufacturing and continuous fibers? My short answer is no, we don't directly address that. My long answer is that in Communion, what we do is tape placement and trying to create hybrid structures through metal and composite in automotive applications. And what we do here as a laboratory is try to assess the interface between the composite and the metal through laser texturing in order to provide the best possible adhesion between the two parts and be able to generate a hybrid part, let's say, that fulfills the needs of lightweight and high strength that is needed for the automotive sector. Onto the pure additive projects. This is actually a project that is nearing completion. It is expected to finish by the end of 2017. It's called Borealis. The target of Borealis was to create the largest additive manufacturing machine available at that time, with a very high throughput and very high efficiency in terms of material efficiency, material capture rate. Borealis involved the design of a direct metal deposition machine, not only the mechatronic equipment, but also the design of a laser head and the optics that consist that solution. Also involved the creation of a laser source that was able to not only do material deposition, but also do material ablation in order to finish the parts and reduce the needs for post-processing when taking them out of the machine. The use cases here, we're dealing with motorsports and aeronautics parts, and this is why the working envelope of the machine is quite large. We are talking about items up to 4.5 meters in length. And as I was saying, right now we are in the integration phase of Borealis. So we are actually working on integrating the different components on the final machine to be demonstrated by the end of the year. Next one is HintCon, again a relatively new project. This has been running for about 1 year, and this is a bit different from what we usually do in the essence that it addresses additive and subtractive manufacturing in the field of construction. So we do have to do with printing of concrete in an essence, and what we are trying to do is to reduce lead time and cost by 20% and increase the build rate by 15%. As LMS, what we do here is again modeling of the process. So we are trying to simulate the way that the concrete is being output from the additive machine nozzle, and the way that the mass growth is happening as the machine deposits, but also try to implement some very efficient path planning algorithms, not only in terms that you need to take into account the solidification of the material as it exits the machine nozzle, but also because you have to take into account accessibility issues on the machine. And last one is actually what I talked 15 minutes ago, is the DiHybrid project. It's something that we have been working on for the past 8 months. DiHybrid aims to reduce significantly the machine price compared to commercial solutions and reduce the life cycle costs involved in repair, but at the same time allow the end users to significantly reduce their spare parts inventory by providing solutions for inside repair and reduce their workflow space. This is a very important project for us. It is a very important project in general because it addresses a very hot topic, the topic of integrating additive manufacturing to actually address problems not in a clean room situation, not in the factory, but out on the field, and allow repair of large structures. Last one is a project that just kicked off 1.5 months ago. It's a project called Amable. It is part of the I4MS projects, and what Amable does is aiming to create a service arena to allow uptake of additive manufacturing by European SMEs. So it aims to develop a digital AM services arena where anyone that wants to use additive manufacturing or wants to learn about additive manufacturing but doesn't have the resources to do so can come to and they can come in any phase of the idea development, let's say, from very initial concepts up to someone that just wants to do a verification if the design is okay and needs to print a prototype, up to people that need to do a batch production. And a series of services will be provided through that platform by also addressing things like data integrity and data security in order to be able to establish a European ecosystem of additive manufacturing nodes. What is important here is that the Amable project is actually holding a series of open calls on the next years for SMEs to participate on that in a cascade funding topic. So on February 2018, we are holding an open day at Fraunhofer in Aachen, Germany, where SMEs and companies are very welcome to participate and get informed about the project and what we do. And if interested, they could also be informed about the specific details of the open calls that will come up in late 2018. That would be all from my side. If you need any more information, you can send an email to Dr. Stavropoulos. He's the head of the Advanced Manufacturing Group. So if you have any ideas on any possible collaborations or anything to discuss on the topics that we do, or if you need any more information, please get back to us. We would be very happy to discuss with you.